with number 15.
Number 15.
Mm-hmm.
Okay. So let's look at number 15. All right, I'm gonna. All right, is this number 15 the same as the number 15 you have?
Yes.
X squared minus 2x minus 3 divided by x squared plus 11x plus 30.
Yes. Yes.
So let's take the top part, and we're going to factor it. So now when we're done, we're going to have x plus or minus something times x plus or minus something. And here in this problem, we're looking for numbers that multiply to -3 that combine to -2. And 3 is prime.
Mm-hmm.
So we're going to put 3 here and 1. And then because it's -2x in the middle, when it's combined, it needs to be -2. So we're going to put the negative on the 3 and the positive on the 1. And then, so when you're not commenting or asking a question, if you wouldn't mind turning off your mic, thank you. All right, x squared plus 11x plus 30. We've got x times x, and here we're looking for two numbers that multiply to 30 that combine to 11. And so let's see. Because it's positive this time, they either both have to be positive or they both have to be negative. And since 11 is positive, they'll both be positive, which means that those numbers will combine, they'll add to 11. And so numbers that multiply to 30 and add to 11 would be 5 and 6. So I'm going to put plus 5 and plus 6. The order doesn't matter. Could have put x plus 6 times x plus 5. It doesn't matter. So now that we've got it all factored, this is less than 0. Now we we look at each one of those separately here. Here, x equals -1. Because if I put -1 in here for x, -1 plus 1 is 0. Over here, x equals 3, because 3 minus 3 is 0. Here, we say x equals -5. And when you're looking at the denominator, it's always never can it be equal. So I'm going to say x is not equal to -5. But we're going to still graph that in our set. And here, x cannot equal -6, because -6 plus 6 is 0. The reason why that's important in the denominator is because you cannot divide by 0. And so it could not be part of the solution here. And then we're going to focus on this part here for just a moment, the idea that it is less than 0. And that is, that means it's negative. So now we graph all of these numbers. We're going to start with the one that's furthest to the left, which would be -6. And then -5. Then we've got -1. And I realize it's not drawn to scale, but we get the idea. -1, and then just for reference, we'll put 0 in here. And then we've got 3. So then we take each one of these points and we think about what could we have to put on them. The ones on the bottom cannot be equal, and so we use open dots for them. The ones on the top can also not be equal to 0 because it says less than 0, not less than or equal to 0. And so we're going to put open dots in each one of our numbers that we've found here. And then we're making this sign chart. And we consider each one of these numbers separately. So at -6, to the left of -6, it will be negative, and then positive to the right. Then we look at -5, and to the left of -5, it'll be negative and positive to the right. Then we go to -1. -1, negative to the left, positive to the right. And then 3, negative to the left, and positive to the right. Then we go through and we multiply out to find out what is the resulting sign. When you have an even number of negatives, here I've got 1, 2, 3, 4 to the left of -6. And if you multiply those all out, negative times negative would be positive, negative times negative, positive, and positive times positive is positive. So this would be a positive result here to the left of -6, which means that the graph of this would be above the x-axis. On the next one, we have 3 negatives, and so that would be a negative result. In the next instance, we've got 2 negatives, so negative times negative would be positive. This would be positive here. And in the next one, we have just the 1 negative, and so it would be negative. And then to the right of the 3, it would be positive. So we're looking then at the intervals where they're negative, and that would be right here and right here. And so our solution set goes in between those two. So we fill that in here. And there. And then in interval notation, we would write that our solution set goes from -6 to -5, and we're using parentheses. And then this is joined or union with, that's what the U means, -1 to 3. And all of those are parentheses because they're all open circles. It can't be equal to any one of those numbers, but it includes all of the numbers in between. So this -6, comma 5, sorry, that should say -5, means that it's all of the numbers between -6 and -5. So -5.5, for example, would be included. -5.1, -5.9. It does not include -6 because -6 is an open circle. At -6, it would be equal to 0. And so In solution set, this is the answer, but then the graph is also important. Okay. Did you have any questions about that solution, Valentina?
So, in the denominator, always it will be unequal to the x, like the x, it's always unequal to the number that we give you.
It cannot be equal. That's correct. Yeah. It will always not be equal to the values that would make it 0, and the reason for that is that you cannot divide by 0. When x is equal to
Okay.
-5 plus 5, that's 0. And because it's in the denominator, you would be dividing by 0, which we know is one of the big rules in math. You cannot divide by 0.
Okay.
Yeah, it's a good question. Which other ones would you like to go through?
Mm,
Valentin or Victoria, feel free to speak up if there's one that you would like to go over. Should we go over one of the ones at the beginning?
yeah.
Let's go. Go over number 2. Okay, number 2. I'm gonna change colors. Let's change this to green. So this one, it's already factored. X minus 2 is a factor, and x plus 4 is a factor. So we don't have to factor them sooner. We can just look at those and say x equals 2, and x cannot equal -4. Here, 2 minus 2 is 0, and -4 plus 4 would be 0 as well. And that's why I put, again, that cannot equal -4 because you'd be dividing by 0. Then we analyze the idea that this is greater than 0. What kind of numbers are greater than 0? Either one of you, Valentina, Victoria? Someone else joined our meeting?
So what's the question? Wait.
What does it mean that something is greater than 0? What do we call those numbers that are to the right of 0?
Negatives. Oh. Wait. Positive. Positive.
Positive, right? Good. So positive numbers. So when we're finished with this down here, we're going to have some positive numbers. So I'm going to put -4 down here. And 2. Really just including 0 for reference. So then we're going to have our sign chart. And we consider each one of these numbers. So -4 to the left, that's negative, positive, positive. And then 2 to the left is negative, negative, and positive to the right. And so a negative times a negative is positive. Negative times positive would be negative. And a positive times positive would be positive as well. And because we're looking for positive numbers greater than 0 or positive numbers, these are the intervals where that will happen. And so if it were equal, we'd use, if it was greater than or equal to 0, we would use a closed dot on our numbers that we have. But since it's strictly greater than, we use an open circle to show that it cannot be equal, but will start at that point. And so we use an open circle both at -4 and at 2. And then those are the intervals where this happens. So it goes off to the left here, and it goes over here off to the right. And that's the graph of the solutions. Now what we do is include the intervals. So this goes clear off to the left. It goes clear to -infinity. And it goes to -4. Combined with the part on the right, which is starts at 2 and goes clear off to the right, which is clear off to positive infinity. All right, does that make sense?
Yes.
Should you do 1 or 2 more?
Yeah, I wanna try with number 11.
All right, let's look at number 11. Okay, once again, with number 11, the nice thing about number 11 in this case is that it's already factored out, so we don't have to factor it. We've got x plus 10, x plus 1, x minus 3. And so we can just take each of the numbers that results from that. What is the number that would cause x plus 10 to equal 0?
-10.
Exactly. So x equals -10 here. How about x plus 1?
X equals -1.
Exactly. And x minus 3?
X equal to 3.
Very good. So now we've got
But
3 numbers. We're going to go and graph them. So -10, -1.
but here
3. Sorry, go ahead.
okay, so now here all of them are equal to the number because there's no denominator, or
Right. If it had this equals to sign, then they could be exactly equal to this. Now, I'm writing x equals -10, x equals -1, x equals 3, just to show that these are the zeros of this. But when I'm actually graphing it, I'm going to use an open dot because these are the places where if this were an equation, if instead of less than we had equal to 0, then this would be exactly correct. This is a place where x equals -10. This factor would be equal to 0 when multiplied by the others would cause them to be 0 also. Same with x equals -1 and x equals 3. But because it's x is less than 0 strictly without the equal sign underneath it, we we could say x is not equal to 10, to -10, but these are just the points that we're going to take down here, and the open circles are what we're using to indicate that this is strictly less than 0. Now, about that, since it's less than 0, then we know that the answer is going to be negative. And so we're going to consider our sign array, our sign charts or array. So to the left of -10 would be negative, and then positive, positive, positive. To the left of -1 would be negative in each of those intervals, and positive to the right. To the left of -3 would be negative, and positive to the right. So then we multiply out negative times negative times negative. There's an odd number of negatives, which would be negative. Here, negative times negative would be positive. And here, negative times positive would be negative. And positive times positive would be also positive. So because we're looking for negative results, those that are less than 0, then these are our intervals here, negative here and negative here. So this goes off to the left. And then we have the intervals in between these two here. And so in set notation, we'd say this goes from -infinity to -10, union, -1 to 3. And that interval notation is our answer. But as I said before, the graph is important too because it helps us get to that answer. And it's also a lot of times they'll ask you for the graph, and the graph would be your answer. Okay, what other questions do you have, Valentina? Or Victoria?
Number 13.
15, did you say?
13.
Oh, 13. Okay, on number 13, this time we've got this leading coefficient of 2. Let me take a snip of that real quick. So we've got a leading coefficient of 2, so we're going to take 2 times negative 5, which would be negative 10. And the middle number would be negative 3. And so we're looking for two numbers that multiply to negative 10, which is 2 times negative 5, that add or combine to negative 3. Now, since the negative 10 is negative, that means one of the numbers is going to be positive and the other numbers are going to be negative. So I think the numbers are 5 and 2. And since the negative 3 is negative, I think the negative is going to be on the 5. So negative 5 times positive 2 would be negative 3. Sorry, negative 5 plus 2 would be negative 3. Negative 5 times 2 would be negative 10. So at this point, we go to our box. And we put 2x squared here and negative 5 down in the right. And then negative 3x, that's our middle term over here, we're going to put that in the other two boxes using the numbers that we found. So I'll put plus 2x and minus 5x. Now, I could have put them in opposite order. It doesn't matter. So then we're by each row, we're looking for the greatest common factor. So between 2x squared and 2x, what I can take out of both of those would be 2x. And then 2x times 2x squared would be x. Then x times negative 5 would be negative 5x. Negative 5 times, let's say, 1. 2x times 1 would be 2x, and 1 times negative 5 would be negative 5. So our two factors on the top, the first one would be 2x minus 5, and the second would be x plus 1. In our denominator, this x squared minus 4, that's the difference of two squares. And so remember that difference of two squares factors as conjugate pairs. So that's x times x, and then 2 and 2, 1 plus and 1 minus. And then all of this is less than or equal to 0. So we take each one of these and find the zeros. Sometimes it's easier, like in the other prior examples, but 2x minus 5, we can just take 2x minus 5 and say, let's set this equal to 0. We add 5 to both sides. And we get 2x is equal to 5. And we divide by 2. And x is equal to 5 halves. So we can go through and look at all of our numbers. X is equal to 5 halves, comma is one of them. X plus 1, there x would be equal to minus 1, because minus 1 plus 1 is 0. Then we've got x plus 2, and here I'll use the is not equal to sign because they're in the denominator. So x is not equal to negative 2, and also x is not equal to positive 2. And this one's different than the last examples that we saw because now it can be equal to 0. And so the x equals 5 halves and x equals minus 1, those are allowed. But down here in the denominator, those can still not be 0 because it would be it would cause this whole thing to not exist if x equals -2. You can't divide by 0. If x equals 2, here 2 minus 2 is 0, so you can't divide by 0. But in the numerator, you can have zeros. That's okay. And in this case, because it can be less than or equal to 0, then it's going to work. And then we're going to use a closed dot for those two numbers in the numerator. Since it's less than, we're looking for a negative result. So we go back here and we graph them. We're going to start with the one clear to the left, which would be -2. And then -1. Now 5 halves is 2.5. So the next number would actually be 2. We'll put 0 just for reference. The next number would be 2. And then the next number after that would be our 5 halves. We're going to have open dots at 2 and -2. And we're going to have closed dots at -1 and at 5 halves. And then we make our sign chart. So to the left of -2 would be negative, then positive, 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 positive. Then to the left of -1 would be negative, negative, positive, positive, positive. Then to the left of 2 would be negative, 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 positive, positive. To the left of 5 halves, we'd have negative, 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 and then positive to the right. And let's go through each of these segments. Clear over to the left. An even number of negatives, 4 negatives, would be positive. 3 negatives would be negative. 2 negatives would be positive. 1 negative would be negative. And all positives would be positive. So we're looking for the places where it's negative. And that's here and here. So we can fill in the spaces in between here for those intervals, and here. And then we can draw our interval notation, which would be from -2 to -1. Now, this is again another difference where you have -1 and it can be equal to -1. We're going to have a bracket there rather than a parenthesis. Then we have union at 2 to 5 halves. And once again, a bracket at 5 halves. And that would be our solution set for this. That help, Valentina?
Yes, thank you.
You're welcome. Were there any that you would like to go over, Victoria? I'd say let's stop our meeting there then, and let you guys go off and finish any work that you need to do on this, or any of the other things that you might need to do. Sound like a plan?
Yes.
All right. Well, thank you both for coming, and hope everything is going well for you.
For you too.
Have a good day.
You too. Bye.
Bye now.